Hi guys, it's Simon. Welcome to this new AI radar. Let's start. The dailystar.co.uk reports that a new range of artificial intelligence-powered sex robots promises to incorporate deep learning technology that allows them to become more attuned to the user's speech patterns over time and respond more like a real human. The technology hidden inside Sex Doll Genie is so advanced, say the manufacturers, that she can hold short conversation, sing, moan and express pleasure as well as moving her head, neck and lips. In addition to learning her owner's likes and dislikes, the sex robot incorporates advanced touch sensors to enable the doll to feel changes of pressure or temperature on her synthetic skin and react accordingly. She will also tell you to go out and throw the rubbish. Israeli AI computer vision company Nexer partnered with Japanese insurance company Mitsui Sumitomo to release an AI system that automatically reconstructs car accident reports, carandriver.com. Software company Nexer, working with the Japanese insurance company, has released an AI-based system that combines the use of an app with footage captures on vehicles' dash cams to reconstruct exactly what happened in a crash. Next says the system will detect 90% of accidents and lets users submit a report in one click. Interestingly, the 200,000 plus drivers currently using this new system in Japan are paying up to $10 a month for the privilege, not getting a discount from their insurance company. Forbes contributor Jim McGill writes that one way that AI could aid grid operators is in the field of predictive maintenance, using data to keep track of the physical condition of all of the assets on the grid, from generation sources like gas-fired power plants and renewable sources to the transmission lines and distribution networks, all the way down to the thermostats, said Tom Siebel, founder and CEO of C3.ai. Predictive maintenance could detect a potential equipment failure hours or days before an actual failure occurs, they said. Another way in which AI could have helped alleviate the problems seen on the Texas grid in February would have been in providing improved long-term weather forecasts. This could have enabled the grid's operators to determine in advance which units would have to go offline in order to protect the grid's integrity, which in turn would have allowed electricity consumers more time to prepare for planned outages. Traditionally, researchers start out with a hypothesis. Coffee lowers the risk of heart disease, for example. However, in a new analysis of existing data published in the American Heart Association journal Circulation, Heart Failure, David Kao, a cardiologist at University of Colorado School of Medicine, didn't start with a hypothesis. Instead, he used machine learning to look for links between thousands of patient characteristics collected in the well-known Framingham Heart Study and the odds of those patients developing heart failure. An analysis like Chaos can reveal collections no one has thought of. After the link appeared between coffee intake and the reduced risk of heart failure in the Framingham data, Kao confirmed the result by using the algorithm to correctly predict the relationship between coffee intake and heart failure in two other respected datasets. Still, it's not definitive, reports the New York Times. It's part of a growing body of evidence that at the moment can say little about how much coffee people should drink. Nature reports that the computational complexity of deep neural networks is a major obstacle of many application scenarios driven by low power devices like at the edge, including federated learning. A recent finding shows that random sketches can substantially reduce the model complexity without affecting prediction accuracy, reports Nature. Researchers at the School of Information and Communication Engineering, Beijing University of Post and Telecommunications, Beijing, China, built a so-called Universal Compressing While Training framework that directly learns a complete model and, most importantly, enables computationally efficient on-device learning. As validated on different models and datasets, it attains substantial memory reduction of 50 to 90 times compared with fully connected deep neural networks. The researchers demonstrated on low-cost hardware whereby the computation is accelerated by more than 180 times and the energy consumption is reduced by 10 times. They claim their method paves the way for deploying tiny artificial intelligence in many scientific and industrial applications. Okay guys, it's all for today. See you next time. Bye.